that we know and understand how to unit test, to write some code that tests other code, our project. I'm going to head over to main activity, so main Java UI, then main activity. And we have this function here is input valid. And this is the one we could do with unit testing to make sure that we get true or false for the correct inputs. So let's do a first attempt at trying to unit test this. We will not do it in the example unit test file. We'll make a new file. So we'll right click and we'll do a new Kotlin file or class. And we could call this something like main activity test, or we could be specific. So let's call this our input validation test. And we can go ahead and write our first unit test here. So I'll do test, fun, and we'll say input validator. And there's a few tests we could write, and one of them would be that it returns false when empty. So we're testing the input validator, and we need to confirm, assert that it returns false when empty, because empty is not a valid input. So how would we go about unit testing this? Well, looking at our example unit test, you might think, okay, we had a greeter. And so we went ahead and made an instance of greeter and then tested the function. So you might think, okay, we will go ahead and make an instance of main activity. So a new main activity, and then we'll do main activity dot is input valid. Hang on a second, that wasn't auto-completing. Why not? We hover over it. It says it's private in main activity. Okay, so there's the first problem. Because we've marked the function private here, the test class, which is a different class, is unable to see it. So we will have to remove the private function there, make it public. Not ideal, but we'll do that. So now we can do is input valid, and we will just do an empty string like that. Second problem, it's expecting an editable, and this is a string. So we will need to change our is input valid function to accept a string. So let's do that. We'll say it can accept an empty string. That's fine. Then we have an error because we're passing in an editable. So we will simply do safecall.toString to convert our editable to a string. So that's an OK change, making it accept a string or a nullable string, and then just converting our editable there to a string. So now that seems to be OK. We can call that function. So we should capture the result. So the result, if I So let's do that. We'll say it can accept an empty string. That's fine. Then we have an error because we're passing in an editable. So we will simply do safecall.toString to convert our editable to a string. So that's an OK change, making it accept a string or a nullable string, and then just converting our editable there to a string. So now that seems to be OK. We can call that function. So we should capture the result. So the result, if I specify the type, that type will be either true or false. It'll be a Boolean. Don't need to specify the type. And call that function, making it accept a string or a nullable string, and then just converting our editable there to a string. So now that seems to be OK. We can call that function. So we should capture the result. So the result, if I specify the type, that type will be either true or false. It'll be a Boolean. Don't need to specify the type. I'm just showing you that it is a Boolean. So that's the action. We can actually annotate that by saying perform an action. Good way to get thinking about unit tests, performing an action and then assert the result. So we can do assert, well, we could do assert equals. We could do this, assert equals result, and we expect that to be false. We could do that. That is absolutely fine if I just import that. But there's a few other types of assert function, and one is quite simply assert false. So we can pass in the result, and we can just assert that this thing is false. We expect it to be false. So there's a few things: assert true, assert false, assert equals. I'll delete the assert equals import. So we're going to assert that this is false. We expect an empty string to be false for is input valid. But let's see what happens when we try to run this unit test. Oh dear. Not only does the test fail, but specifically we have the red exclamation mark saying it didn't run properly, it didn't complete. And when I click it, we get a stack trace with all kinds of errors. And this one here, Android OS looper not mocked, really confusing sounding stuff, a runtime exception. And this leads us to a very important point about unit tests in Android Studio. Unit tests, in this folder here, they run on the JVM, the Java Virtual Machine, a very simple thing that runs on our development machines. This is not running inside an Android emulator or on an Android phone. And so the problem is, there's all kinds of things in main activity that depends on views, things on the screen, buttons, system things that are available to the Android app. If I command click on main activity, open up the imports, you can see all of this stuff here, starting with Android or Android X. The majority of that is just not going to work at all in unit tests. They can work in the Android test, the ones we run on the emulator, but that is a completely different type of thing with its own challenges to get things set up properly. But for our simple unit tests, we are simply not allowed to make an instance of main activity. And this is the problem, or at least one of the problems, of dumping all of our code in the fragments and activities. Things don't become easily testable. You have all of your stuff stuck together, things aren't separated, and you run into not only problems with testing like this, but also with debugging, and with the code being readable and understandable. You have this ever-growing class of stuff. Okay? So the ability to test things is one reason why we should start to think about separating things out, moving some of the code out of main activity, moving the code out of the fragments. So what can we do? Well, let's cut this isInputValid function altogether. Let's cut it out of main activity. Control X. We're going to have an error there, but that's fine for now. I will leave that error. And instead, let's put this simple function in its own file. Nothing to do with Android. This is just pure Kotlin logic, checking a string, seeing if it's valid or not. And so we will put it somewhere in our main source code. Rather than putting it in the UI folder, because this is now not really UI, we could put this somewhere else. And a very simple solution is to make a util folder for utilities. This bit of code to check whether the input is valid is just a simple utility function. It's got nothing to do with UI, nothing really to do with data that we're storing. It's just a simple function that checks something. So clicking on our package, we can do right click, new package, call it util, and then we have these three folders at the top level: data, UI, and util for utilities. Do take care with making a util folder. They can quite quickly become a dumping ground. There are other places we could put this, but for a small project, it's absolutely fine. We'll do right click, do a new Kotlin class or file, and this time we'll do a simple object. It doesn't need to be a class. We don't need to instantiate this. And we'll call it our input validator. And then inside this object braces, we will paste that cut function. So input validator is input valid. A very simple object with a simple function. So now in main activity, well, that actually went ahead for me and auto-imported that. You could also qualify it with input validator dot is input valid. And then you wouldn't need the import like that. So you could either do input validator dot is input valid, or you can actually remove this and import the function. Both ways is fine. I personally prefer qualifying it with the object. Makes things nice and tidy. So now the code for isInputValid lies inside a separate class, input validator. There's, well, at the moment, no imports whatsoever, and certainly no dependency on any of these Android imports, like main activity has here. So this now becomes much more testable. Not only that, but it cleans up our code a little bit. All the logic for validating input is in its own little file, and main activity is just that little bit shorter, one less function. Can remove those line breaks. So now, in the input validation test, rather than instantiating main activity, we actually don't need to instantiate anything. We can call input validator dot is input valid. I'll remove the main activity import. And when I run this now, the test passes. We can make sure things are working by intentionally failing this. We could do a valid input, something not empty. Make sure the test fails. This is called red light, green light, in the sense that you're intentionally making it go wrong to then fix it to confirm you're not getting a false positive. For example, if you forget to assert, well, the test will pass because we're not asserting anything. So that can be a good approach, to intentionally fail your test before fixing it. But this test is now correct, and we can go ahead now and cover all the test cases that we care about. So it returns false when empty. It should also return false when null. So now we'll change the empty string for something null. Make sure that test passes. Okay. We should test a spacebar. So it returns false when only white space. So I can go and do a few spaces there, and that test should also pass because that is false. We trim that. Very good. We should do a successful scenario, so it would turns true when more than one non-white space character. No problem with a long test name. If it fails, we will know what it means. So I can do more than one character, and that should now be true. We expect that to be true. That is a valid input. So I'll go ahead and import the assert true assertion. So this should now return true. Let's see. Very good. And we should probably test if there's only one character. That is also true, or rather two, sorry, because one is not valid. So it returns true when two non-white space characters. So we'll do A, B. That should be true. Hopefully you can see how quickly I'm doing these small unit tests, testing small behaviors. And it should return false when only one non-white space character. So this should now be assert false again. We don't allow one character. And if I then go to the top of this test class and run all of our input validation tests, quite quickly you see 8 milliseconds, they all pass very, very quick. And I can expand this to see all the test cases that did pass. And we have some protection in our code base. Let's say another engineer comes and changes that to actually just removing the length check. Well, now if we run these tests again, well, one of the tests has failed, and I can see here the input validator, it should have returned false when only one non-white space character, but it actually returned true. So one character would be valid there. So it gives us protection against the behavior changing, going backwards, regressing. So I'll undo that. We want it to be more than one character. I can run the whole test class again, and everything is fine. So we've just flown through there, but what we've done there is we've confirmed that we cannot unit test activities and fragments. And really, it's going to be quite difficult for us to unit test many things to do with the Android views or user interface. So we've had a need to move some of the logic in main activity out of there into a different file, which we've done in this input validator. And shortly we'll be seeing there are some other very useful types of place and file that we can move code to in Android as we start to look at organizing our code and moving things to better places, things that can be unit tested. So we moved it to the input validator object, which can be unit tested, and we've done all of these test cases. If I just collapse the functions, we've done all of these things, copied and pasted a bit, and just changed the expected outcome. So this is a pretty good unit test class, testing one function and testing all the different scenarios we expect to see. So I'm really confident with this test class. There's nothing further we need to do to worry about our input validator. Of course, we're still free to manually test it. However, this test class is doing a lot of that for us. And so at this point, as we finally have a need to move some of our code out of the activity, and later on potentially out of the fragments, it leads to an important question. Should we be putting all of our code in main activity? Should we be splitting things up a bit, moving things around? If we agree that it could keep our activities and fragments a bit more tidy, to not have so much logic and complicated stuff in there, well then, where should we be putting it if not inside an activity or a fragment? Do we make lots and lots of these object classes with little functions like this? Or are there other solutions for where we can do the setup for a screen? And before we go much deeper into the idea of a full-on architecture, it's time now to look at one very, very useful class available to us in both activities and fragments as a place to put a lot of our code. If we consider the activity and the fragments to be the view, the things on the screen, the buttons, well then the place we can put some of the other non-view code is in a thing called a view model. So in the next tutorial, let's finally look at a view model in Android, understand what it is, how it works, and the sorts of things we should start to be putting inside this view model. So let's do that next.